Do you know that all measurement is subjected to measurement error, which can affect our result? And you know that this error can come from different sources. Sometimes it is kind of difficult for us to identify what these sources, where these errors are coming in. So in this video, I'm going to make you understand the difference between accuracy and precision, and how to make your result accurate and your set of data precise when you are carrying out your measurement or what experiment. And you know the difference between what error is, and the sources errors can come into your measurement, and also what the different types of what error. And I'll teach you how to correct your error when you are carrying out your measurement or experiment. What you have to know is that as a scientist, that you have to be careful when you are planning your experiment or making any measurement in order to minimize error or to eradicate error altogether. So error can come in at any time. That is why you have to be very careful when you are carrying out your measurement or plan your investigation. So as you plan your investigation, also plan for sources of error where error can come in your investigation, so that to arrest it immediately before they come in. So the major goal of any measurement or scientific inquiry is to compare what you measured to what is already established as true or accepted value. That is your experimental result. Understand? For example, the standard value for water is what 7, and it's acceptable by the world for pH 7. So let's say you carry out your experiment and you got 6.5. So the goal of what you are doing is to compare what you get to what is already accepted, in order to know whether you are on the right track. You can see that it's very important. You have this skill, this ability. So what characterizes every data or result you get when you are doing your measurement or experiment is to know how accurate it is, or how precise the set of data is. So accuracy and precision are what characterize every data, every result we got in the course of our experiment or measurement. So what is precision? Precision helps us to understand how agreeable a given set of data are to each other. Understand, this data, they agree with themselves. Understand, they really agree with themselves. Understand, so these data agree because of what they are not spread, but they are close. You can see precise results are ones where data is all really close to the mean. Understand, and not spread. Let me show you an example. For example, look at this table now. You can see that this data here, they all agree with themselves, with each other, and they agree with what they mean. They're not like this one that is very spread. You can see this data are very spread, and even spread from the what mean. You can see this data, this set of data, they have high precision, but this one they have what low precision. So what's accuracy? Accuracy describes the degree to which result of an experiment or what you calculate are close to the true value. Understand, that is, to what extent that what you measured is close to what already established as accepted or true value. That's what accuracy is all about. In other words, accuracy refers to the closeness of what a measured value to a standard or known value. You understand? So like the pH you talk about, how close your pH, what you got like that 6.5 to what to already establish 7 is what accuracy is all about. So another example again is if in the lab you obtain a weight measurement of this, and the actual value, what is accepted is this, that means your result is not accurate. In this case, your measurement is not close to the known value. See, it's not. So accuracy helps you to know how close you are to what is accepted, to the target, to what is accepted in reality. You understand? So that's why you have to be very careful when you are doing your experiment to avoid error, because error can affect the accuracy of your result and also your precision of your result. So you have to be very careful when doing any measurement or experiment. So how can you make your results accurate? So you have to repeat your measurement in the same way each time. That is, you have to repeat your experiment and get the average to help you to get accurate result. Use apparatus with small division. For example, if you want to measure the volume of alcohol, maybe about 10 ml, you can say this 10 ml is accurate because of it giving a precise, a target mark. Unlike using this one, the calibration of this one is kind of so high. It has what high division. Unlike this one will just give you 10. So when you want to carry out measurement, use a specific apparatus that will give you that particular amount you want. You understand? You now want to get accurate results. So use your apparatus carefully too. You understand? When you are doing your measurement. For example, there are some students when they are carrying out any titration experiment, they'll forget to remove the funnel forward. They run their solution from the burette. You can see once you are not careful in handling your apparatus, you might end up bringing in error, which will eventually affect the accuracy of your result. So let's talk about the difference between accuracy and precision. Look at this stuff here. You can see that all these, they are not accurate and they are not precise because the data are spread. That's why they are not accurate, and they are not close to the bull's eyes. Yes, and this point, this target, so that's why they are not accurate. On the other hand, look at this one. The data are close, they are not spread, so they have a high precision but low accuracy because they are not close to what is accepted or true value. Look at this one. These values are accurate because they are close to the point where it is acceptable, but the data are kind of spread. You can see they are spread. They have low precision. Here the data here are accurate and precise. They have high precision because of what they are close, they are not spread, and they are on the spot, which is not acceptable. Because this is the difference between accuracy and precision. So look at this another example again. I got this from this textbook. You can see here, this is the acceptable value, the result or area. The one at the top here is the average, this is the average, this is the average, and this is the average. You can see this value there, they have high accuracy. No, sorry, they have high precision because they are not spread down on one spot, but they have low accuracy because they are far from this point, which is the target area. Here, it has high accuracy because of the average is close to what is acceptable, but the data are spread, they have low precision. Here they have low precision and low accuracy because the data are spread and they are not close to what is acceptable. Here they have high accuracy and high precision because the data are close to what is acceptable and also close together. So let's talk about error. So error is just the difference between what you measured and what is not acceptable. So this is the formula for error. We call this absolute error. You can see is the difference between what you measured to what is actually acceptable as a true value. If the experimental value is less than the accepted value, the error is negative. If the experimental value is larger than the accepted value, the error is positive. For example, if what you measured is 5 meters, for example, and what is acceptable is 6 meters, when you get the difference, you get a negative value. That means your error is negative. But let's say you measured 7 meters and what is acceptable is 6. When you get the difference, it will give you +1. So that means your error is positive. So that is what these things are trying to say. So let's quickly talk about the relative error. It is the ratio of the absolute error to what is acceptable. And we can convert it to percentage, and we call it percentage error by multiplying by 100. So it is always good to leave your error in percentage because it helps you to know your margin, that is how far or close you are to what is really accepted in terms of what percentage. And what you have to know is that a percentage error of 1% to 5% of your acceptable value means that you are still in line. So let's quickly solve this question. Let's say the accepted density for aluminum is this, and when you carry out your experiment, you got 2.42. For you to calculate your percentage error, all you just need to do is to subtract the accepted value from what you got divided by this, multiplied by 100, you get this. So you can see it's very simple and easy to understand. So why do we calculate percentage error? Engineers use it to determine the precision of a measuring instrument. In the financial sector, statisticians and data analysts rely on it to verify if a data set is progressing in the right direction. We can also use it to know how close our results are to the expected value in terms of percentage. A 4% error tells you that you are actually close to the what is acceptable, while 60% tells you that you are very far away from what is acceptable. Also, in we can apply it when we are making baking. For example, we want to want to bake a cake, and the required recipe is 4.5 spoons. You can try to go with 4 or go with 5. So the difference in error will be about 10% of, and it still give you what you actually need. You can see that's what a variety of what application. So error can come in at any time in your result. It can be from a limitation of the instrument you are using or the experimental setup or design you are applying. So that's why you have to be very careful when you are planning what your experiment. So common source of error, we have the environmental error. Error can come from the environment, like changing weather condition, like relative humidity and all that. It can be instrumental error based on the limitation of the instrument you are using. It can be the procedure you are using. Maybe you are using the wrong procedure to bring error. And also, human error means when the person is incompetent, when the person is not experienced, and again, if the person have any kind of disability, or if the person is sick. When you are sick, you do things sluggishly, and end up bringing what error in your measurement. So we have types of error. We have human error caused by human. It can be carelessness of the person or incompetency of the person. We have random error. Random error is if there's a small variation in your result, and it can be environmental when the environment unpredictably changes which affect the result of the equipment. It can be observational error when the observer's judgment leads towards random inaccuracies. I will explain later. It can be we have systematic error, that is if you consistently have what wrong result at every given time. What you have to know about systematic error is difficult to correct because of it can be from the experimental setup you design, or it can be the limitation of the instrument you're using. It can be in form of environmental, observational, and also what instrumental when the instrument is flawed and cause consistent inaccuracies in your what you're reading. It can be observational when the observer does not read the measurement correctly. You can see where you're not reading correctly and you're still repeating it. You see what end up getting wrong result. You can see random error can be corrected by what by repeating the result and getting what the average. So environmental error when the surrounding cause problem with the lab, that is the lab we are using can also contribute to affecting what your result. It depends on the condition. That's why sometimes it's advisable to change lab and use another lab to see whether you get the same result. So example of systematic error, look at this measurement. Even when there's nothing here, it's still reading on 2.0 milligram. Now such instrument will add more to the value. Instead of giving the right value, it will add more to the value. Look at a gauge a gauge counter which measure what radiation. You can see here is giving you the accurate result, but when you bring a phone close to it, because of the phone releases radio frequency, it will add to the reading and increase what the value. You can see this is what we call environmental error. That is, you don't know that your environment is affecting your result, and you end up getting the same, consistently getting what the same what negative what result. Also, observational error. You can see here, instead of to look at this on the lower meniscus, is looking at it at the above the lower meniscus. You can see the person will interpret this reading as what 40 mil, but in recent, when you look at the lower meniscus or through the normal eye level, you give you 4 mil. You can see these are observational error, and this is also what human error or personal error. You can see that error can come anytime. Systematic error is very difficult to eradicate, and it will affect what the accuracy of your result. You understand? Systematic error affect the accuracy of what of our result. For random error, you can see when you consistently when there's consistent variation in your result, you know that this is what a random error. What you have to do to correct it is to add all these things together and get the average to give what a good what result. Yes, and that thing again, it can be environmental error. For example, when getting a pressure reading, students were entering and what exceeding what the lab, causing the pressure to what to lower. Yes, and at this as students are coming and going, it will affect the pressure of your reading. Yes, and instead of giving you this actual reading, to give you something like this lower reading, you can see that it can be environmental and it can be what. Yeah, what about random error? You can easily identify it and what correct it. But systematic error, sorry, what about random error? It is difficult to identify and correct it. But systematic error, you can easily identify it immediately and correct it. You can see the difference. So the solution now for random error, you can correct by in order to address random error, scientists utilize replication. Replication is the repeating a measurement many times and taking the average. So when you repeat the measurement, take the average, you what correct what random error. For systematic error, careful experimental design and control. Design a good experiment. Proper equipment maintenance, that is maintain the experiment you want to use, the equipment you want to use before you use it. Training of laboratory personnel, careful observation and record keeping will correct the systematic error. Because this is the solution. On the final note, error cannot be completely eliminated. That's what you have to know. But it can be reduced by being aware of common source of this error and by adopting thoughtful and careful method. You can see error is it is difficult to eradicate error, but by taking a careful measures and applying all these things you have learned today, you should be able to remove them or minimize them. Please and please don't forget to subscribe to my YouTube channel. One of the main reasons of this academic channel is to help you get better in academics. I will always give you insightful tips, ideas, and advices that will help you grow in academics. My name is Mr. Igwe Chijoke, and I'm a teacher and I'm also a chemist. And so please subscribe to my YouTube channel and always visit my YouTube channel. And if there's any question you want to ask, you can comment on the comment section below, and I'm willing to answer you. Thank you. Bye.